Each year, billions of square feet of ceramic tile are produced around the world. Its appearance is as refined as natural stone, yet inside lies a densely compressed, sintered mineral structure strong enough to resist scratches, moisture, and heavy loads for decades. Ceramic tile is made from refined clay blended with base minerals, then processed at high temperatures to achieve long-lasting strength and color stability. A mineral-based glaze on the surface protects it from UV exposure, chemicals, and wear, preserving its beauty over time. But have you ever wondered how such dark, raw materials can be transformed into bright, polished, and remarkably durable tiles? In this video, we'll explore the world of ceramic tiles, the flooring material that has reshaped millions of buildings across the globe. Though it looks simple on the surface, the global ceramic tile industry generates more than $120 billion every year. Its production network spans over 60 countries, with China and India leading thanks to stable raw materials and strong processing capacity that supply a major share of the world's output. Every year, more than 170 billion square feet of ceramic tiles are produced, an enormous volume supported by tens of thousands of fully automated production lines running around the clock worldwide. Durable, stable, and long-lasting, ceramic tiles are not just materials. They are the foundation that shapes modern living spaces and the appearance of cities around the world. The first stage begins at the raw material quarries, where clay, white sand, and feldspar are extracted. Feldspar is a mineral rich in alumina and alkalis, and it plays a key role in strengthening the tile and giving its surface a smooth, glossy finish. At open-pit quarries, the topsoil is stripped away to reveal a weathered layer of clay that is lighter in color and soft enough for mechanical extraction. Excavators remove it in thin layers, cutting the material into large, clean blocks without the need for drilling or blasting, which helps maintain consistent clay quality across the entire mining zone. Each bucket load is quickly inspected by eye to remove any oversized rocks or remaining organic debris. Right after being excavated, the clay is dumped directly into high-capacity haul trucks. These trucks run continuously from the mining area straight to the plant's intake point, where all incoming material enters the primary crushing stage. Here, the clay is loosened, broken down, and cleaned of embedded stones to standardize particle size before moving into deeper processing steps. Direct transport from the quarry to the primary crusher keeps the material fresh, limits moisture variation, and preserves the uniformity required for a stable ceramic tile production line. After the initial crushing stage, the clay is transported to the plant either by enclosed conveyors or by dedicated hauling trucks, depending on the distance and the layout of the quarry. The goal is to deliver the material in a loosened, stable condition, free from clumps and with minimal changes in moisture. Once it reaches the raw material processing area, the flow of clay is directed into an automated routing system. Sliding gates and control valves divide the material into different paths: temporary storage, additive mixing, or preparation for fine grinding. These storage bays are engineered to prevent sticking and to keep the clay in an ideal state for the next stages. Thanks to this routing process, the clay leaving the primary crusher is organized into clean, consistent material streams, fully prepared for fine grinding and the formation of the clay slurry. From the routed storage bays, the clay is fed into the fine grinding system, where ball mills play a crucial role in reducing the material to the particle size needed for ceramic tile production. Inside the grinding chamber, thousands of porcelain or quartz balls move continuously, striking and abrading a pre-measured blend of clay, feldspar, and silica. With constant rotation and high compressive force, the mixture is ground to a fineness of just a few dozen microns, forming a uniform suspension. After the clay, feldspar, and silica mixture is finely ground, it is pumped continuously into large slip tanks, where the material exists as a slurry, a smooth suspension capable of dispersing evenly in water. These tall cylindrical tanks are engineered to minimize sedimentation, with high-power agitators running non-stop to keep the mixture gently moving so the mineral particles do not separate over time. Throughout storage, the slurry is adjusted only at a minimal level to to achieve the proper viscosity and density, ensuring a stable flow when it is pumped into the next processing stage. Any small variation in fineness or moisture content is balanced directly within the tank, allowing the mixture to remain uniform. With this level of stability, the slurry can maintain consistent quality for many hours, forming a solid foundation for the spray drying and powder forming steps that ultimately determine the strength and performance of the finished tile. From the slurry tanks, the mixture is pumped into the spray dryer, where the liquid feed is atomized into fine droplets and dried almost instantly by a controlled stream of hot air. This process transforms the material from a wet slurry into granulated powder with low moisture, uniform particle size, and the right flowability for shaping. By the time it reaches the bottom of the drying tower, the powder has already achieved the ideal condition for pressing, without the need for additional intermediate steps. The entire output is collected continuously and transferred directly into short-term silos before being fed to the presses, ensuring a steady, uniform material flow throughout the production line. From the short-term silos, the granulated powder is released into the feed chamber of the hydraulic press. Thanks to its loose, uniform condition after spray drying, each batch flows smoothly into the mold, filling the entire cavity without leaving voids. As the mold closes, a massive hydraulic force, often reaching several hundred tons, compresses the powder into a solid block with the exact shape of the tile. In this instant, the material begins to transform. The powder particles lock together under pressure, forming a green body that is firm enough to be handled, but still extremely fragile. Each pressing cycle is monitored by force sensors, fill level controls, and precise timing to ensure every tile achieves the same density and thickness. This repeatable accuracy makes the press a critical stage for achieving flatness, strength, and consistency across the entire batch. Once the green body is pushed out of the mold, its surface already carries the precise geometry it needs to advance to the next step in the production line. Right after pressing, the green tiles still contain residual moisture and are not stable enough to withstand the next handling steps. They are sent through a rapid dryer where a controlled stream of circulating hot air removes moisture in a gradual, uniform way, preventing sudden shrinkage. Within just a few minutes, the moisture imbalance is corrected, giving the tile body greater stiffness, reduced warping, and enough strength to move along the conveyor without chipping. As the tiles leave the dryer, their moisture level is low and consistent, allowing them to maintain precise shape for the upcoming surface treatment stages. With continuous, synchronized operation, the drying system produces a steady flow of evenly dried tiles, ensuring stable quality throughout the entire production process. After leaving the dryer, the green tiles enter the glazing area, where a base layer of glaze is applied to create flatness, whiteness, and proper adhesion for the decorative layers that follow. Depending on the design, the line may use one or both glazing technologies: roller application and pressure spray application. At the roller station, a large rotating drum picks up a thin film of glaze from the reservoir and transfers it directly onto the surface of the tile as it passes underneath. This method produces a smooth, uniform coating that masks tiny imperfections in the tile body and forms a stable base for subsequent treatments. The thickness of the layer is controlled by the drum speed, glaze viscosity, and the gap between the roller and the tile surface. Immediately afterward, the tile may pass through a spray booth, where high-pressure nozzles atomize the glaze into a fine mist and distribute it evenly using compressed air. This method allows the addition of functional glaze layers, such as those providing gloss, depth, or specific surface effects. Many factories combine both techniques to achieve a smooth, leveled base and a final glaze layer that meets the exact visual and technical requirements of the design. By the time the tile leaves the glazing section, its surface carries a stable and uniform glaze layer, fully prepared for high-precision decorative printing. Once the base glaze layer is fully applied, the tiles move into the digital printing area, where their patterns are recreated using inkjet technology with near-perfect precision. ceramic print heads release ultra-fine droplets of ink, only a few dozen microns in size, allowing the image to bond directly onto the still wet glazed surface. Guided by software control, every stone, wood, or concrete pattern is rendered with the exact tone and depth intended by the designers. The inks used in this stage are heat-resistant mineral pigments, so once they adhere to the glaze, their color separation and sharpness remain intact even after exposure to extreme temperatures later in the process. A network of sensors constantly monitors conveyor speed, tile flatness, and the exact position of each piece, ensuring that every droplet lands precisely where it should, without misalignment or distortion. By the time the tile exits the printhead's surface already carries a nearly finished appearance. Crisp images, smooth color transitions, and high detail, creating the impression of real natural stone, real wood, or any other material the factory intends to replicate. Once the glaze and printed pattern are fully formed, the tiles enter the roller kiln, where temperatures can reach more than 2,200 degrees Fahrenheit. In this intense and continuous heat environment, the glaze begins to vitrify, fusing with the tile body and creating a hard, glassy surface with exceptional gloss, depth, and scratch resistance. At the same time, the mineral structure inside the tile body undergoes sintering, developing the mechanical strength that defines ceramic and porcelain tiles. The roller conveyor moves each tile through carefully controlled temperature zones, from preheating to peak firing to a managed cooling section. Although the process is continuous, the temperature curve is precisely regulated in each zone to prevent warping or internal stress. Within just a few dozen minutes, the once soft, freshly glazed tile is transformed into a finished product with a fully stabilized surface and permanently fixed colors. As the tiles exit the kiln, they achieve a level of flatness, hardness, and color stability that remains unchanged over time, reflecting the quality of every stage, from raw materials to firing technology. When the tiles leave the dryer, their surfaces still carry a thin layer of fine dust from the granulated powder and tiny particles generated during handling. To remove these impurities, each tile passes through a rotating brush unit, where soft bristle rollers sweep across the top surface. The rotating motion provides gentle contact, just enough to lift away the microscopic dust, while a vacuum system beneath the line immediately captures everything that is brushed off. By combining rotary brushing with direct suction, the tile surface becomes clean and stable, free from loose particles that could cause pinholes, smudges, or blurred details during glazing. In just a few seconds, the tiles emerge in a smooth, clean, dry condition, fully prepared for glaze application or high-precision digital printing. Right after cleaning, the tiles move into the inspection area, where each piece is examined under strong lighting to detect even the smallest surface deviations. The extreme temperatures inside the kiln can create very subtle variations in flatness, gloss, or color uniformity, and this is where sensors and technicians work together to determine whether a tile meets the required quality. High-resolution cameras scan every piece, comparing it against program specifications, while inspectors focus only on the points flagged as potential defects. Dimensions and flatness are also checked using contour gauges and automatic flatness tables. Even a deviation of a few hundredths of an inch can disqualify a tile from the top-grade category. This precision ensures that, once installed, the tiles align tightly without differences in height or visible gaps. Pieces that fail the visual or dimensional standards are sent either to a lower grade or to a recycling stream, depending on the type of defect. Thanks to this continuous and systematic inspection process, every tile that passes through this stage carries consistent quality, reflecting the strength and accuracy of the production line from raw materials to final firing. After passing the inspection stage, the qualified tiles move to the packaging area, where they are grouped into batches according to their exact size and color specifications. Each stack is arranged neatly on the conveyor so that tiles support one another, minimizing any impact during handling and transport. An automatic counter determines the precise quantity for every box, while robotic arms place the tiles into carton trays or wooden pallets with just enough force to avoid chipping. Around each palletized load, shrink film or PE wrap is applied in multiple layers to secure the entire stack, keeping it stable throughout its journey. Labels, technical specifications, and production codes are printed onto the identification tags, allowing distributors to trace the origin easily and ensuring consistent delivery across the market. By the time the pallet reaches the shipping area, every stack is stable, clean, and fully prepared for long-distance transport, from regional warehouses to construction sites around the world. From raw clay to a fully finished tile, the production of ceramic tiles is a transformation of natural minerals into a material that is both durable and visually refined. Through fine grinding, spray drying, hydraulic pressing, glazing, and high-temperature firing, each tile is formed with remarkable stability and colors that remain virtually unchanged over time. Behind the smooth, flawless surface we see every day lies an entire chain of precise industrial technologies, all working together to ensure consistent quality before the tiles reach the hands of users. If you'd like to explore more fascinating industrial processes like this, don't forget to subscribe and leave a comment below. Tell me which material journey you want to see next. Your suggestion might become the next story featured on the channel.